So we will continue with the scenarios wherein a particle or a extended rigid body is in equilibrium, which means the sum of all the forces and sum of all the torques acting on the particle, acting on the body are zero. And when dealing with the static frictional force, keep in mind that the maximum static frictional force is equals to mu mg, and the actual static frictional force may be anywhere between 0 and mu mg. You have mu mg when you are given the about to slip situation. When you know that the body is about to slip, that's when you can assume that the frictional force is mu mg. Otherwise, it will be somewhere between 0 and mu mg. So you guys comfortable with whatever has been discussed so far in the last few classes? Let me quickly go around the table. Chavi, you are comfortable beta, in how to apply the torques to be 0, some of the forces to be x, y, and z direction?
Yes, sir, decently.
Okay. And Ruchika beta, you are comfortable as well? So let's start with number 5 and 6. We're going to focus on number 5 and 6. So we're going to cover 2 to 3 questions from each. And after that, I'll be walking you through about 12 to 15 questions from JEE Advanced level practice questions. Okay, you'll not be expected to solve them during the class, but I'll be discussing those. So that'll give you a good idea about some interesting scenarios involving the particle or the extended rigid body in equilibrium. So what's so special about number 5 and what's so special about number 6? Number 5 involves a 3-dimensional body like a cubical block or something which the dimensions are significant enough, and it is subjected to some frictional force as well. So you have to apply some of the forces to be 0, that is summation fx equals to 0, summation fy equals to 0, summation tau z equals to 0. And in number 6, we'll be dealing with scenarios where we have a mass or a block sliding on a rough or a smooth incline. Now the incline, which is typically would be the incline of a wedge, now the wedge may be free to move on the ground. So there might be further friction force between the ground and the wedge. So we'll deal with all such scenarios. Now in number 5, let me briefly talk about the scenarios that you will expect to see, and then we'll jump into some practice questions. So essentially, you will look at 2 scenarios. In one scenario, you are pulling the block in such a manner that it does not topple. It does not topple, but it undergoes some translational acceleration. In the another scenario, you might be interested in finding out what should be the friction force such that it does not move translationally, but rather it topples around one of the edges. Okay. Now in the scenario B that it is shown here, you have 2 ladders which are placed against each other. So once again, these 2 are the examples of extended rigid body. What do I mean by extended rigid body? The body for which the dimensions are significant enough that we have to account for the torques as well. Okay. And whenever dealing with torque, Manan, I'm not sure beta if you were in the class. So whenever we're writing tau z equals to 0, for example, in the case of ladders, now the first question that you have to ask yourself is torque about what point is 0, or torque about what axis is 0. Make sure you always define very clearly in your head about what axis you're writing at, right? Now, if you're writing tau z, now that axis can be anywhere in the xy plane, will not make any difference, okay? So you will still get only one equation. You cannot get multiple equations, multiple independent equations by writing tau z equals to 0 about different axes. So that will be not of much help. Anyway, so you guys remember the drill. You'll be asked to solve maybe 2 questions to 3 questions, and then we will move on to the tougher or more challenging JEE Advanced practice level questions. So let's begin with it. Yes, beta.
तो उसमें टॉर्क जीरो क्यों होगा?
Because the ladder is in equilibrium. And how do we know that the ladder is in equilibrium? It says its feet rest on the floor. Its feet rest on the floor. So whenever the body is in equilibrium, sum of all the forces and sum of all the torques must be zero. Yes?
Yes, sir.
Okay. रुचिका बेटा, छवि,
सर क्लियर है।
छवि बेटा इतनी देर क्यों लग गई अपनी? आई वॉज एक्सपेक्टिंग कि आप लोग जल्दी से कर लेंगे ये, सो प्लीज डू हेल्प मी अंडरस्टैंड कि ये कहाँ पर इट टुक लिटिल बिट लॉन्गर फॉर यू गाइस, कहाँ देर लगी? फोर्सेस में तो क्लियर है ना, वॉल फ्रिक्शनलेस है, तो द फ्रिक्शनल द ओनली फोर्स दैट द वॉल कैन अप्लाई इज द नॉर्मल फोर्स, राइट? So it can only apply a normal force which is always perpendicular to the contact surface, perpendicular to the wall. ठीक है ना बेटा?
यस सर।
Okay. उसके बाद में all I did was to find a convenient point about which we can write down the torque equals to zero. Look to me, if I were to take the torque about A, then I wouldn't have to worry about the forces, reaction forces from the flow. So I got my FW by writing torque Z equals to 0 about point A. Once I got my reaction force from the wall onto the ladder, then I was able to quickly write summation of forces along X direction to be 0 to find out the FFH. That means the horizontal component of the reaction force from the floor. And then similarly, I wrote the summation Fy equals to 0 to get the vertical component of the reaction force from the floor. Clear hai? Yes, beta. Next one. We have to be quick.
Sir,
Yes, beta.
sir, एक doubt था, I forgot to ask you last time also कि what exactly is reaction force?
Reaction force is whenever two bodies are in contact, right? So one body is applying certain force on, let's say in this case, ladder is applying certain force on the ground. Yes? And ground in response is applying certain force back on it, which is the reaction force, right? Newton's third law, action and reaction. So in other words, reaction force is the net force which is acted upon by the floor or the one of the contact surfaces on the other body in contact. Did that make?
So वो तो normal ही हो गया।
बेटा डिपेंड करता है, अगर if there is no friction force, अगर friction नहीं है तो सिर्फ normal force हो जाएगा, अगर friction force है, so as in this case, floor वाले केस में the reaction force is actually net reaction force. It's neither horizontal, neither vertical. It's at an angle. It's at an angle to the floor.
Yes, sir.
I remember a student asked a question, कि sir, ladder है, तो how come ladder पे ऐसे नहीं लगता force ना, right? So well, one way to think about it is if you, unless the ladder is digging into the wall, if the wall is fairly rigid, then no matter how small So if you were to zoom into this contact area, you will see that the ladder actually has some radius of curvature at that point. Okay? And wall is tangent to that. The reaction force is always perpendicular to the wall if there is no friction. If there is no friction, then the reaction force is perpendicular to the wall. The normal force is perpendicular. Okay, let's move on. Let's do one NT Abhyas or one JEE Advanced. Let's see what do we have in JEE Advanced. 2020 question. Let's do this one. Yes, बेटा. Manan, Ruchika. Chavi.
So clear है.
सारे क्वेश्चन जा सकते हैं.
Sure, beta. Chavi, beta, you are attempting it. Do you need some more time?
No, so I'm pretty sure I'll stop.
Okay. तो इसमें I hope the math is right. So I'll go with that assumption. Let's understand the logic behind the question. So what they are saying is that initially your left finger is at the 0 mark and the right finger is at the 90 centimeter mark, not the 100 centimeter. Right? So as you can tell, the normal force on the left finger would be greater. Would it be greater or would it be less?
So left finger के लिए greater होगा.
Greater. Okay. Good. So the left finger one will be greater. So in which case the frictional force between the scale and the right finger is less than the one on the left finger, right? So the static frictional force of the right finger is less than the static frictional force of the left finger. That's why the right finger slides towards the left. Now, as you are sliding it in, now, by the way, as soon as you start sliding the finger, your kinetic friction comes into play. Your coefficient of friction is not 0.4 anymore, it's 0.32. Now, there will come a point where your the two forces will again become equal. Which two forces? The normal force times the kinetic friction of the left finger and the did I do it the other way around? Okay, so I'm trying to find the first scenario where the left finger slide, but the left finger is less, no? The reaction force on the left finger is less.
Yes, sir, that's what I was thinking.
Right? Because the torque,
Left में more नहीं होना चाहिए.
with the arm length, no? So let's see. वो जो
So left के लिए arm length greater है.
हाँ, do you remember the lever वाला concept ना? जितना दूर होगा उतना ही आसान है लिफ्ट करना ना. तो आपके अगर सेंटर से देखें, ठीक है, सेंटर के अबाउट अगर आप ले लें, तो सेंटर के अबाउट जो टॉर्क होगा वो दिस हैज टू बी ग्रेटर ना देन दिस वन. करेक्ट ना? तभी तो टॉर्क्स बैलेंस रहेंगे लेफ्ट फिंगर राइट फिंगर का ना. सो लेफ्ट फिंगर
Yes, sir.
force would be less compared to the right finger to begin with. ठीक है बेटा?
Length of arm के inverse proportional होता है.
करेक्ट. तो अब वो दोनों फिंगर्स अपन अंदर लेके आ रहे हैं. सो देयर विल कम अ पॉइंट, नॉट दोनों, अभी राइट वाली अब स्टक है एट द 90 सेंटीमीटर मार्क, लेफ्ट वाली आके रुक जाती है XLY because at that point its kinetic friction becomes equal to the static friction of the right finger. Okay, after that the right finger starts to slide. अब जैसे वो स्लाइड करने लगती है, it becomes the kinetic friction of the right finger. Where again there will come a point where the two frictional forces will become equal, right? तो उसको आसान, उसको तसल्ली से you have to just walk it step by step and write down those two equations. It's not very complex figure. You just have to patiently write down your equations. Correct, no?
Yes, sir.
Okay.
Sir,
Yes, beta.
so जो आपने अभी बताया वो I understood, right? I did not understand how to put it in the equations.
Okay. So I think where बेटा आप जहाँ अटक गए हो ना, वो कहाँ अटक गए हो? That let me see if I can explain it. आप कहाँ अटक गए? आप अटक गए इस पे जो इक्वेशन 1 जो मैंने मार्क कर रखी है ना यहाँ पे, वो इक्वेशन 1 को फ्रेम करते वक्त आपका थोड़ा कंफ्यूजन आ गया मेरे ख्याल से ना, कि मैं फ्रिक्शनल फोर्स, राइट, वो तभी फिंगर रुकेगी ना जब फ्रिक्शनल फोर्स सब बराबर हो गए. ठीक है ना बेटा? अब जैसे अगर वो नहीं रुकेगी लेफ्ट फिंगर, तो लेफ्ट फिंगर थोड़ी सी आगे जाएगी तो इसका फ्रिक्शनल फोर्स विल बी मच मोर देन द राइट वाले का फ्रिक्शनल फोर्स. इट कैन नॉट मूव एनीमोर, राइट? तो और कौन सा फ्रिक्शनल फोर्स है लेफ्ट वाले भी मूव कर रही है, उसका काइनेटिक फ्रिक्शनल फोर्स हैज टू बिकम इक्वल टू द स्टैटिक। करेक्ट ना बेटा? तभी रुकेगा ना।
यस सर।
और जैसे रुका अब इसका फ्रिक्शनल फोर्स बढ़ गया, हालांकि रुका हुआ लेफ्ट फिंगर उसका बढ़ गया। नाउ इट्स द स्टैटिक फ्रिक्शनल फोर्स दैट कम्स इनटू प्ले वंस इट स्टॉप्स। तो जब पहला इक्वेट करेंगे रुकेगा कब? जब काइनेटिक फ्रिक्शन ऑफ द लेफ्ट फिंगर बिकम्स इक्वल टू द स्टैटिक फ्रिक्शन ऑफ द राइट फिंगर। तो उसको कैसे लिखेंगे? म्यू टाइम्स NL, ये NL और ये क्या है? राइट फिंगर का रिएक्शन फोर्स इज NR, लेफ्ट फिंगर का NL। 1 and 2 are the initial position and the final position. Similarly for the left one, 1 is the initial position at 0 centimeters, second is the position at XL. पहले वो XL निकाला, उसके बाद में बेटा XR निकाला। करेक्ट ना बेटा? क्लियर? यस बेटा जी,
यस सर। हाँ
ये कर लेना आप। मेरा किया हुआ मेरे काम आएगा, आपका किया हुआ आपके काम आएगा। उस प्रिंसिपल को याद रखते हुए बेटा कर लीजिएगा। एनीवे इट्स टेकन अस लॉन्गर देन आई एंटिसिपेटेड, लेट्स मूव ऑन। अभी वी डोंट हैव द बैंडविड्थ टू टच एनी मोर क्वेश्चन, सो आई एम गोना जंप ऑन टू द नेक्स्ट क्वेश्चन टाइप। अब वेज वाला आएगा। वेज वाले में 2 सिनेरियोज को मैं डिस्कस कर लेता हूं, उसके बाद विल जंप इनटू द क्वेश्चंस। आपने एक ब्लॉक रखा हुआ है, ब्लॉक स्लिप नहीं कर रहा, राइट? ब्लॉक स्लिप नहीं कर रहा। अब एक एक्सटर्नल फोर्स हमने लगाया ब्लॉक पे। अब वो एक्सटर्नल फोर्स 2 डायरेक्शन में लग सकता है। एक लग सकता है पॉइंटेड अपवर्ड्स और एक है लग सकता है पॉइंटेड डाउनवर्ड्स, राइट? तो क्वेश्चन ये पूछ सकते हैं कि फॉर what magnitude of the force will the block slide vertically upwards, and for what amount of force will the block start to slide down the incline? Okay. Now, what is the difference between the 2 scenarios? Well, if you are pushing up the incline, then the frictional force would be acting downwards, down the incline, right? The frictional force will be acting down the incline on the block. But if you are pushing it from or pushing the block down the incline, then the frictional force is acting up the incline. Is that part clear? So let me explain. Too many words. Sometimes it's very hard to follow the words. So let's see if we can draw it up. Let's say I'm putting this force, applying this force F, and so let's just talk about this scenario. Within this scenario where we are pushing the block up the incline, you might be asked to find 2 different forces, minimum and maximum force for which the block will not slide, right? So what do we mean by minimum force? So this is scenario number 1. What it means is if you don't apply the force F, then M would be sliding downwards. Let's say the coefficient of friction is mu. And let me draw the forces here. This force is your mg cos theta. Now, if F is not there, then the block would have the tendency to slide downwards and the frictional force will be acting upwards, right? So this is scenario A. Let me draw it separately. I'm talking about minimum force.
So मैं फिर mg sin theta minus mg cos theta हो जाएगा.
Right. So this way will be your mu mg cos theta. Here will be your F minimum. And in this direction downwards is your mg sin theta. Yes, Peter? are not drawing the forces perpendicular to the incline. Clear? So F minimum plus mu mg cos theta is equals to mg sin theta. So F minimum is mg sin theta minus mu cos theta. Clear? Yes, Peter? We have to be quick, Peter. So please do give your responses quickly, because only then I can got many grounds. If I have to ask the question twice, then we're going to waste time. So you guys are smart enough to understand what I mean. Now let's talk about the maximum force. The maximum force scenario is where you are pushing hard enough, where the block is about to slide in the upward direction, which means now the frictional force is acting in the downward direction. And
सर बस प्लस साइन आ जाएगा फिर.
this is your mg sin theta. You are absolutely right. So F maximum will be mg sin theta plus mu cos theta. Okay. Now, what is the other scenario? Let's say you are pushing it downwards. Now, assume that mu is greater than tan theta. If somebody can explain what this is, then that'll be quite nice. What does mu greater than tan theta imply? Mu greater than tan theta implies if you do not apply any force. By the way, I should have shown this angle theta. This is the angle theta. So mu greater than tan theta means if you leave the block without applying any other external force besides the gravitational force and the normal force and the friction force, then the block will not slide downwards. Why? The maximum force here is mu mg cos theta. And this is mg sin theta. In the about to slip situation, what should be mu in the about to slip situation? Mu will be tan theta. So if mu is greater than tan theta, that means there is more in the reserve for the frictional force, and the block will not slide. So the frictional force would not reach the maximum value. But if mu is less than tan theta, that means mg sin theta is greater than mu mg cos theta, and the block will slide downwards. So assuming that mu is greater than tan theta, how much force is needed to push it downwards? Well, it's a simple math now. You can draw the free body diagram. Make sure you do not make any silly errors when drawing the free body diagram. After that, you should be all set. You just simply have to write the limiting condition. You just have to balance the forces along the incline. Okay. Let's start and let's go ahead and practice a few questions.
So जो केस में जिसमें हम नीचे से फोर्स लगा रहे थे, that is where mu is less than tan theta, right?
Where we were applying the force from the minimum force. When I'm trying to find the minimum force, right? What did that minimum force correspond to? The scenario where I am just applying enough force so that the block is not sliding downwards. Well, that automatically indicates that mu must be less than tan theta. You are right.
Yeah. Yes.
Okay. Let's quickly solve two questions. Please pick up the pace if you can. Do not try and panic. Do not rush. But if you can increase the alertness, please go ahead and solve these two questions. One JEE Advanced, one JEE Mains. For the students who would listen to this lecture on YouTube, especially for the class 11 students, as they are building the skill to correctly draw the free body diagrams and correctly draw the directions of the forces, it will take quite a bit of practice to achieve that level of comfort. So it is highly recommended that you practice as many questions from this chapter as you can. It is definitely going to pay you or give you a good payback. Now, in this question, in these type of question where the force is not along the incline, you will have to take the components of the force along the incline and perpendicular to the incline, and then write down your balance of forces.
So 12 होगा क्या?
Is it 12, beta? Yep. Shall we move on?
Yes, sir.
Yes, sir, मेरा गाड़ी.
Okay. 2020 question. Since we have not done the rotation chapter, for the rolling motion to happen, there has to be a net torque either about the center, or you can think about the net torque about the point of contact. Okay. In the direction.
So मेरा ज्योमेट्री से ये आ गया.
Geometry से ये आ गया.
So बिना रोटेशन लगाई आ गया.
बेटा बिना उसके नहीं किया आपने. कॉन्सेप्ट तो वही यूज किया है, जस्ट दैट instead of thinking through all the steps, you intuitively have done those things. ठीक है ना बेटा? जो आपने कहा ना, इसका सेंटर मस्ट बी राइट अबव इट ना, जो आपने लॉजिक लगाया, उस लॉजिक का तो यही मतलब हुआ ना बेटा?
Yes, sir.
That logic itself is based on that science, better, that the rotation mg should be just so that mg, because if it's any further, if the ball comes here, then mg would have a moment arm, will apply the torque, or will result in a torque about this point O, point of contact O.
Yes, sir, ये आ गया.
ये आ गया?
सर मुझे जैसे मनन ने कहा वैसे तो समझ आ गया, बट आई डोंट नो हाउ टू डू द एक्चुअल थिंग.
Okay. बेटा आप थोड़ा सा बताएं क्या चीज समझ में आई. इफ यू कैन आर्टिकुलेट व्हाट डिड यू or how you felt intuitively that Manan's approach is correct and it makes sense, because the underlying physics is hidden in that intuition. I just want to bring that out. Can you try and articulate, beta, why it felt intuitively right? That when your center of the ball is just vertically above the point of contact, that will be the limiting condition. Yes, beta?
Sir, because I thought कि like अगर theta ज़्यादा होगा, like from the picture that you've drawn, if the theta is more, then the R का arm will come like onto the slope, right? Like beyond the hole. So then it will roll forward. That's what I thought.
Right. Right. It's the same thing. Let me draw another equivalent scenario. So let's say you have a T kind of structure, right? It is balanced. The center of mass is located along this line. But if you put some weight here, right, center of mass shifts. The net center of mass shifts. And if you keep putting weight, there'll come a point where it reaches just this point beyond this, beyond the what do you call that? The foot impression. As soon as it goes beyond that, then about this point, mg, let's say net center of mass is here, then it will apply a torque about this point, and it will just topple it over. Now you might wonder what is center of mass. Don't worry about it, right? सुन लिया बस, दिमाग में कहीं रख लिया, उसको आगे जब चलेंगे अगले चैप्टर में आएंगे तो धीरे धीरे चीजें समझ में आने लगे. ठीक है बेटा, मोटा मोटा आप क्या सीख रहे हैं? टॉर्क के बारे में भी आप started to become slightly comfortable. Now typically most of the times the coaching institutes will not touch these questions till they get to the rotation chapter, but nothing wrong in playing around with torque itself, right? Because in equilibrium conditions, you don't have to worry about the Newton's second law in rotation form, right? Which is tau equals to IL or tau equals to DL by dt, the more generic form. So here, just knowing the definition of the torque, you can solve the problems. So why not learn about the torque now rather than later? Okay. So I think we are done with these two question types. Now, how much time do we have left? Okay. Let me just jump in. And let's begin with some good practice questions. I'll do the explaining. You guys have to keep up with me and you can ask me questions if things are not making sense. Okay, beta? So number 5, continuous mass or external rigid bodies. We'll begin with this one. So what do we have here? So we are given a solid cube which is placed on a horizontal surface. The coefficient of friction between them is mu, where mu is given to be whatever less than half. It says a variable horizontal force is applied on the cube's upper face, perpendicular to one edge and passing through the midpoint of that edge. Okay. The maximum acceleration with which it can move without toppling. So how would we think about this? Let me draw a side view. Now, when it is about to topple, what will happen? It will slightly lift off from the ground such that this left edge is not in touch anymore. Only along this edge is the block in touch with the ground. Okay. So let's understand what forces are or how forces are interacting and avoiding the toppling condition, toppling scenario. Right? So you have, let's say it's about to topple. So if all the weight is along this edge, now mg, which is acting at the center of the cube, is acting downwards. Now, if you were to think about the torque about this axis, then mg, for which the moment arm is this one, So mg times, let's say this is a, so mg times a by 2 is trying to keep it from toppling, right? It's applying a torque in this direction. The force F is actually applying a force in this direction. Correct, Amita? And what is the
Yes, sir.
how much is the torque? Now, because we are talking about the toppling about this edge, not this one vertex or one corner, but rather along the entire edge. So we have to take the shortest distance from the axis of rotation. So this is the distance we're talking about, which is again A. So this should be equals to F into A. Now they talk about the maximum acceleration. Well, if you write down your net forces in the horizontal direction, so what are the forces? You have force F, and then you have mu, because you're after all sliding. So you have the kinetic friction. Mu mg comes into play when you are sliding, right? So F minus mu mg is equals to ma. From here, looks like F should be mg by 2 in the limiting scenario. And mu is given to be less than half. You can see why that is. Otherwise, it will not move, right? If mu were to be greater than half, then your net force would be, you will not have a positive force in the negative means actually the force is in the leftward direction, or the, I should say the maximum frictional force has not been reached. So there will be no movement. But since mu is less than half, we can write this and we can figure out the maximum acceleration here. Okay, let's move to the next question.
सर एक डाउट था
Yes, बेटा जी.
सर जब हम टॉर्क कैलकुलेट कर रहे हैं won't friction apply a torque in the direction of the force, the same direction as the force?
Won't friction apply what?
So like I don't know why I like when I try to pictorially think of it, it feels like when the box is on its edge and the force is pushing it, won't the friction also be kind of like applying a torque to it?
Oh yeah, sure. Okay, so what you're saying is, you were to write so what you're saying is, let me write the torque about the center, right? If I were to think about the torque about the center, then you have frictional force, which is acting along this direction. And then you have the frictional force F acting in that direction. Okay. Give me a second here. Yes, beta? That's what you're saying, no, beta? This is force F. And this is your frictional force. Then you have your normal force in this direction like this. Correct?
Yes, sir.
Okay.
So अगर friction नहीं होगा, then the box won't topple, right? Like will not that, right?
It's actually an excellent question. Well, we're about to make a fundamental error in here. Whenever we are accelerating, Ruchika, Anand, beta, you have to pay attention. Whenever we are accelerating, you should write your torque equation about the center of mass, right? Whenever you are linearly accelerating, then your torque equation should be about the center of mass, right? Not about this edge. God. Why? Because if you think about the torque equation, tau equals to dl by dt, then you do have dl by dt. What is the angular momentum? Angular momentum is dv by dt. Angular momentum is mvr. mv, this is mv into a by 2. M into a by 2, and then you have dv by dt, which is the acceleration. This a is the edge length. Maybe I should have changed from a to something else, but that's okay. So your net torque about this axis should give you this equation on the right hand side. Aha. Okay. Whoa, that was that was a fundamental error we were about to make. Anyway, so let's write down forces about the center of mass. The torque about the center of mass. What do we have? So we have the normal force, which is N times A by 2 minus capital F, or this should be equals to capital F into A by 2. So N is trying to rotate it like this about the center of mass, and the two forces F and the small f is trying to rotate it clockwise. So F into A by 2, that's the moment arm. Similarly, for the friction force, the moment arm is this, again A by 2. And F is nothing but mu N, and N is nothing but mg. Right? So simply N is equals to F plus or mg N is equals to mg if I balance the forces in the vertical direction plus the friction force, which is mu times mg. So your maximum force is mg1 minus, wow, but have I made any mistake here? This is so capital N is trying to rotate the other way around. So the capital N times A by 2. So that's gonna try and rotate in the other way direction. And you have F, which is mu mg 1 minus mu. Okay. Then the maximum acceleration would be how much? Maximum acceleration would be F minus the frictional force, which is mu mg, is equals to ma. So what do we get? So we get 1 minus 2 mu into mg is equals to ma. So A is equals to g 1 minus 2 mu. Have we left anything funny in there? Have we missed out on something? G into 1 minus 2 mu. Let's quickly check the numbers. Beta N is mg, The capital F is acting in the direction. So the torque should be equals to 0. The frictional force F is mu mg. So we got that. This is equals to m times. Okay, so the F is correct. And then F minus the frictional force is equals to mass times acceleration. So that should give us G times 1 minus 2 mu. So let me actually double check this question. This is actually a fundamental question, which I completely lost track of the acceleration part, even though the options are given to be, I think the correct answer must be C here, which is what you will get if you write down your torque balance about the edge, which will be incorrect, This is one of those very rare scenarios where I'll double check my numbers again, but there's a good possibility that whoever has made the question, they made that slight error, just like I had overlooked it. I think they have overlooked it. Gosh, this is a very fundamental. Ruchika, Manan, beta, Chavi, make a note of this question, beta. This is actually quite important. Anyway, let me go to the next question. Are we clear on what I'm talking about or not really?
So we're here.
Okay. Now, this question we couldn't finish yesterday, right?
Yes, sir.
Okay. Again, fairly good question. So what do we have in here? This is a Manan. This is a smooth sphere, and you're applying a force F, and this is the mass M. The string is massless, and the pulley is frictionless. Okay. And the question says, as the mass moves along the smooth hemispherical surface, then which of these options are correct? Whether the tension will increase or decrease, or whether the normal between the ball and the sphere increase or decrease. Okay. So let's quickly draw the free body diagram. So let me just draw a bigger picture of it. Chavi, beta, you are clear on the question, no?
Yes, sir.
So the normal force would be acting perpendicular to the tangent at that point. And let's say this is the angle theta. Okay. Now, this is not what I wanted to show. Let me just pick a different point so that you can see the other angle fairly well. Let's say the mass is here. This angle is theta, and this is your tangent. Let's call this angle as alpha. This angle as 90 minus theta. Normal force is acting on the mass M in this fashion. Mg is acting downwards, and the tension T is acting along the thread. Now, Manan, since there is no friction, since the pulley is frictionless and the rope is massless, so would you agree with me that the F and the tension would be the same at all times?
Yes, sir.
Okay. Now, what they have given is that the mass M is being moved slowly, which means that the mass mass is in equilibrium at all times, right? That's why there is no acceleration. That's what moving very slowly means, or moving slowly means. So this is the normal force, this is mg, and this is the tension force. Okay, so let me draw these forces because these are all concurrent forces. So I'm going to draw them in a triangular fashion. So let me see if I so this is my normal force, and this is the tension or the friction force. Okay, correct, na beta? This is mg and this is the normal force. Let's draw the angles here as well. So this angle is 90 minus theta. This angle is 90 plus alpha, right? 90 plus alpha. What will be this angle? Can I write this angle as theta minus alpha? After all, 180 minus 90 minus theta minus 90 plus alpha, right? So you'll get theta minus alpha. You can do the math in your head. Okay?
Yes, sir.
Let's write down the sine rule. So what does it say? It says sine of theta minus alpha divided by n is equals to sine of 90 minus theta upon t is equals to sine of 90 plus alpha divided by mg. Correct, na beta? Let's first look at these two. So sine of theta minus alpha divided by n is equals to sine of 90 plus alpha by mg. Now sine of 90 plus alpha is nothing but cos alpha. Yes. So cos alpha.
Yes, sir.
Okay. Now let's get back to this triangle. This is my r. This height is fixed. This is h. And this is distance is L. Okay. Now, if I were to write the sine rule, same sine rule in here, what do I get? So I'll get sine of theta minus alpha divided by r is equals to sine of 90 minus theta divided by L is equals to sine of 90 plus alpha divided by this height h. Yes, beta?
Yes, sir.
Quickly see, Ruchika, can you quickly see if I use this and this, what do I get? Sine of theta minus alpha divided by sine of 90 plus alpha, which is cos alpha, is equals to r by h, which is constant. Yes? So what does that give me? Using this and this, that gives me the n by mg is also constant. Correct, na beta? Since the r and h are not changing, your n is not changing. So your normal between the ball and the sphere does not change. Correct?
Yes, sir.
Yes, sir.
Okay. Now let's look at the other one, which is the tension T. So I'm going to use the same thing and you can pick any two relations. And what you will get is, let me just do the math here. So T by N is equals to sine 90 minus theta divided by sine of theta minus alpha, which is nothing but L by R, or T is equals to N times L by R. Just patiently think through it, you will get it. Now, N is constant, as we just concluded. R is constant. What is happening to this L? This L is decreasing, no? Here the length was this much. Now the length is reducing. Correct?
Yes, sir.
The tension must decrease. So this means that this force must decrease if the mass were to move at a uniform speed. Slowly. I shouldn't say uniform speed. If the mass were to move very slowly without any acceleration. Got it? Next question.
Yes, sir.
Okay. So let me get back to this question type. We did number 7. Let me touch on number 11. So we have a wedge here. So the question says, Now there is no acceleration. There is no acceleration in here. Okay? It says a horizontal force F is applied at the top of the equilateral triangle block having mass M. The minimum coefficient of friction required to topple the block before translation will be how much? So there should not be any translation moment. So you can straight away write the balance of torques about, let's say, point C. So F is acting along this. This is the moment arm for the force F. Mg is acting downwards. This is A by 2. Correct? So they'll give you the condition for, it says, the horizontal force F is applied at the top of the equilateral triangle block having mass M. The minimum coefficient of friction required to topple the block. Okay. So first of all, you find out the minimum force required to topple, which will be F into A root 3 by 2 should be equals to mg into A by 2. So you will get your minimum force required to topple it. Then it says minimum coefficient of friction. Well, for the minimum force, what should be the frictional force which should resist it? So that will be mu m, the limiting scenario when it's about to slip, mu mg must be equals to this force F. Yes, beta? Clear?
Yes, sir. सर इसमें लेकिन सर सी के अबाउट बना भी सकते हैं
सी के क्या करवा सकते हैं बेटा?
और जीरो
हाँ सी के अबाउट ही करवाना है. अभी तो लिखा है ना एफ इंटू ए रूट 3 बाई 2 इक्वल्स टू एम जी इंटू, क्योंकि यहाँ पे एक्सेलरेट नहीं कर रहा है. पुराने वाले में चीज एक्सेलरेट कर रही है, वहां नहीं कर सकते. whenever you have a body which is accelerating, always write the torque balance very carefully, right? ये कई बार बड़े बड़े कोचिंग इंस्टीट्यूट से भी ये एरर हो जाता है unknowingly because you are thinking so quickly. It's not a judgment on anybody बेटा, ठीक है, लेकिन वो गलती नहीं करनी है. वहां पर tau equals to dl by dt लिखना है, right? That will give you the same thing as f equals to ma. ठीक है बच्चा?
यस सर.
वहां पर सेंटर ऑफ मास के अबाउट करना है आपको. Anyway, so I'll take another look at it and reconfirm. How much time do we have? I think we have overshot our this thing. So we are a little bit behind. So let me just quickly show you the kind of questions so that you have an idea. Here you have a rod which is bent. Rod's mass is 2m, and the cylinder. And it says a frictional force is acting like this on both of them. Both the surfaces, and it's equal. It's given that the frictional force is equal. Then they're asking कि normal force यहाँ कितना होगा, यहाँ कितना होगा. Well, if you write torque balance about this center O, then let's first figure out where the center of this 2m is. इसका center of mass कहाँ है? That's very important to find out. That's here. Then you can find out its moment arm and write down the torque balance. You will get the force F. Once you get the force F, you can write the forces along the x direction to be 0, forces along the y direction to be 0, and you will get your normal forces. Feel free to challenge and say, sir, ये तो समझ में नहीं आया, so that I can keep moving. If you don't speak up, I'll assume you guys are getting it. बड़ा इंटरेस्टिंग प्रॉब्लम है. क्या गिवन है? ये एक केज है, ठीक है, केज है, स्मूथ है अंदर से, देयर इज नो फ्रिक्शन, म्यू इज 0. एक इन्होंने सो दे हैव केप्ट अ हॉरिजॉन्टल प्लेटफॉर्म, दैट मींस देयर इज नो फ्रिक्शन हियर एट ए और बी पॉइंट्स. नाउ द इंसेक्ट स्टार्ट्स टू मूव फ्रॉम ए. क्वेश्चन इज how much time will it take to go from A to B? Now what is the trick behind it? Given क्या है? Given so the insect moves in such a way such that the platform and the cage they are in rest. तो एक बार देखते हैं. इस प्लेटफॉर्म का सेंटर ऑफ मास तो बिल्कुल इसके नीचे है, so there is no reason for it. There is no torque about the center C. But if you look at the insect, right, or there is no torque about let's say this is going to move about this one, so there is no torque about the center O. तो अब insect जैसे ही, as soon as the insect comes into the picture, now insect has a mass, correct no beta? Now the insect is gonna if I were to draw So let me actually again write the torque about the C, right? If the torque is not balanced about C, because why it's not balanced about C? Because if the insect is standing, then there will be a, let's say the mass is M. So there will be a torque and the platform will tend to go like this, correct? So what does the insect have to do? Insect has to run, right? Accelerate. And what will cause the acceleration? The frictional force, right? The frictional force will cause the acceleration of the insect. Okay. So what will be the direction of the frictional force on the insect? Well, it will be in the direction in which the insect is accelerating, so towards right. So what is the reaction force? What is the frictional force that's being acted on the platform? Well, that will be in this direction. Now, if you look at the forces acting on the platform, then you have mg acting in this direction, right? And then you have the frictional force acting in the backward direction. Right? Correct, no, beta? So now, if you were to write down your torque balance about this point, correct, about the torque about this point, then what will you see? You will see that this force is trying to rotate it like this. Mg is trying to rotate it like this. The two torques will balance out. So you can find out the frictional force as a function of the position, and then you can use the tricks you've learned in kinematics to solve the problem. I'm sure it looks a little bit scary, but don't be scared. Once you get into it, it's just about writing step 1, step 2, step 3 will automatically come. Let me quickly jump on to the next one. This is the same continuation of the same. Here you have a heavy chain left hanging like this. At this point A, you have the angle is given as 37 degrees, which means that the tension force is acting along that line and making an angle 37 degrees. And then you have to write down, or you have to figure out the minimum coefficient of friction between this part, which is on the table here. You have to, right? So if you just look at this stretch, so this stretch would be, what will be the frictional force? What will be the tension that will avoid, that will keep this in equilibrium? So here is a tension force as T dash. Tension is not uniform throughout. Tension is changing. Okay, tension is changing. So T dash at this point, mg somewhere here is acting in the downward direction. You can figure out, you can write down T cos theta, T sine theta, and figure out the tension here in terms of the mg. Okay, here. And then once you know the tension, the frictional force between the table and the rest of the chain, which is on the table, should be sufficient to counter or to provide that tension. Okay.
Sir,
Yes, beta.
so वो tension वाला part नहीं समझ आया.
Tension wala part. This one. Which part?
Yeah.
Tension is not the same.
Yes, sir. I can understand the tension is not same, but like I don't understand how to calculate the tension. on
Oh,
the other
okay.
side.
So if you have T dash here, this angle is given as 37 degrees. So you will say T cos 37 is mg, T dash sine 37 is this tension T. If you divide the two, your T dash will go away. You will get T in terms of mg.
Acha, sir. Huh, okay.
Yeah?
Yeah.
Not every time do we have to apply the torque balance. Sometimes things can be simple. And then the last question in this question type number 5, we have not touched the number 6, but I think we're running out of time. Once again, you have two ladders. They are asking for friction force. We have already done this. You can figure out the amount of friction needed to keep it in this position. Okay? Shouldn't be that difficult. Whoa, there was a lot of questions. So next time you guys have to help me. So we have to finish our 4, 5, 6 questions up front in the first half an hour so that I can discuss these questions in the later half. Okay, so we're gonna break now, and thanks for your patience. Any questions, you can catch me in the next class, Peter. So just before we get started, we'll have the question and answer session there. Any closing comments?
No, sir.
मोटा मोटा समझ में आया कैसा रहा आज का सेशन? रुचिका, मनन, छवि, ज्यादा तेज चला गया, समझ में नहीं आया, कैसा रहा बेटा?
सर पूरा समझ में आ गया।
पूरा समझ में आ गया क्या? मनन,
सर आगे समझ में।
आगे से। छवि बेटा,
सर ठीक था।
हाँ, पीयर प्रेशर में नहीं आना बेटा। स्केल ऑफ 1 to 5। छवि बेटा कहाँ पर है अपन?
सर like 4 I would say.
Whoa, that's pretty good. God bless बेटा. Ruchika, you're also 4 and above.
Yes, sir.
Manan, 4 and above.
Yes, sir.
Your teacher must be very good, okay? You guys are awesome. Alrighty, I'll see you tomorrow, okay? Take care, beta.
Thank you, sir.
Bye, beta. Bye.
Bye, sir.
Bye.